Excuse me. Hello everyone, and welcome back to another episode of Developer's Commentary. However, this time, instead of talking about various things that were included in the game, I'm instead going to explain how to use one of the development tools of the game. So get your affairs in order, Sergeant, because this is gonna be a bit technical. But enough of this weird dilly-dallying, or whatever the hell you freaking call it, and let me show you how to use the SMG RPG level editor. So last time I teased about this special little folder. It's the SDK folder which contains this thing, the level editor. Actually, before we continue, I need to put up a little disclaimer. You see, the levels in the game technically aren't even called levels, they're actually called maps. The maps used by the game are stored in the Simon's RPG map format, and the level editor is actually a map editor. And so this terminology shall be used from this point forward. Okay, well that clarification was nice and everything, but how can we actually use this thing? Well, I already said that we were gonna do that at the beginning, so why are you asking that question? It's freaking redundant. So enough of this stupid filler, let's get freaking started. So when looking at the map editor screen, we immediately can notice two distinct areas. They're this thing and this thing. This thing, on the top, is the toolbar, which contains various tools and information like tile data, music, and buttons for saving and loading maps. The bottom section is the tile map, that is the map itself. However, before we can actually get started making a map, we have to import a tile set for the map to use. In the context of SMG RPG, a tile set is just a collection of 32 by 32 pixel tiles. To add the tileset to the map, we have to click the Import Tileset button, which will bring up this dialog box. With this, we then have to select an image whose width and height are a multiple of 32 pixels. The SDK folder comes pre-built with 5 tilesets to choose from, 4 of which are actually used in the game. While you can use a custom tileset elsewhere on your computer, in this example we're going to use tile1.png. Once imported, we see the first tile in the tileset appear on the top left of the toolbar. But what does this entail? Well, if you look at the bottom here, you'll notice that there's a little copy of that tile that's on the top left, but a bit smaller. This is your selected tile, and to build a map, we're going to have to learn how to move it, of which there are multiple ways in which we can accomplish this. For one, we can left-click to move the selected tile to the mouse's position. In addition, we can click and drag, which will become relevant shortly. Finally, we can use the W, A, S, and D keys to move the selected tile through the tile map. To actually place a tile on a tile map, we have to press Enter. As you can see, a new tile has appeared in the location of the selected tile when we pressed Enter. However, this is only the first tile on the tile map. How do we place anything else? Well, it's actually pretty simple. If we press Q and E, we can actually scroll through the various tiles found in the tile set. Looking at this number, we can see which specific tile in the tile set we've actually selected. Now, if you look closely, you might notice that the tile IDs are kept in base 16. This just means that the tile number is kept track of using digits from 0 to 15. If you ever find it necessary to have to jump to another part of the tile set, you can just use the page up and page down buttons to skip 16 tiles. With this, let's get started in actually building a level. If you ever find yourself having to fill in a large area with the same tile, well, here's a little trick for you. If you click and drag the tile and press shift, you can actually place a whole bunch of that tile. It's a neat little time-saving trick I included in order to make map development a little bit more tolerable. Here's one of the new developers of the game making a little test map for himself. His username is Captain Derp. Ugh. Of all the names you could have chosen, and you chose Captain Derp. Thankfully, I've renamed him to El Capitan, and don't worry, you'll thank me later. So making a map is great and everything, but it means nothing if we can't actually, play it. So like any self-respecting editor, the map editor allows you to go ahead and save your maps to a file. However, for the game to actually recognize that the map exists, we have to put it inside of res/maps instead of the default directory sdk/out. I'm naming this map bridge.srmf, and you'll see why shortly. Now we can't just play the map just yet, because if we try to open it up in the map viewer, the game will just crash. This is because we forgot to put in an entrance point. Looking at El Capitan's footage, we can see that there's an add entrance button, which is used to add entrances to the map. Just click on where you want the entrance point to go, and it's placed. But what if we end up placing the entrance point in, say, the wrong place? Well, there's an easy fix for that. Just click the delete entrance button on the toolbar and click on the entrance that you want to get rid of. Then just click add entrance again and replace the entrance. Now if we look through the tile set one more time, we'll notice that there's a couple of bridge-related tiles. This not only explains the name of this example map, but it will also bring up an important dilemma you'll likely face when designing these sorts of maps. But before we can get to that, we have to, get started placing the bridge, and we already have a problem. Now try as you may, you're actually not allowed to place two tiles on top of each other. Although granted, we're not trying to put this tile on top of the grass, but rather we're trying to replace the tile underneath it. The solution is similar to how we replaced the entrance earlier, although we don't have a delete tile button on the toolbar this time. And although we don't have a delete button, we do have a delete key. That is, to delete a tile, press the delete key, and then to replace it, press enter. Alright, I've built up a little bit more of the map here, and now that we've gotten past that small issue, we can now deal with the main dilemma that I was pointing at earlier. Now if we scroll through the tile map all the way to tile 1B, we'll notice that there's a handrail that goes alongside the bridge tiles. Now what we want the handrails to look like in relation to the bridge is something along the lines of this. That is very similar to how they're actually used in the main game. Now while the top handrail can be placed without issue, it's when we get to the bottom handrail that it starts to get a bit more tricky. Now as stated earlier, you can't place tiles on top of each other, so you won't exactly be allowed to place this top handrail on top of the bridge. But you see, I was actually lying when I said that. Kind of. Let me explain. Now it is true that you can't place tiles on top of each other, but that only applies if they have the same Z order. Now when talking about Z order, I find it best to explain it as a series of layers that are rendered on top of each other, with the lower layers on the bottom and the higher layers on the top. Our map so far only has one layer, as we've only been placing tiles on Z order 0, as can be seen here. The solution, you might therefore think, is to place tiles on Z order 1, so it looks something along the lines of this. And while you are thinking on the right track, there's something else that you have to take into account. Now while placing the top handrail on Z order 1 allows us to have it render on top of the bridge, we also want the top handrail to render on top of sprites. This initially creates a problem because sprites always render on top of Z order 1. The solution should therefore be obvious: we move the top handlebar to Z order 2 instead of Z order 1. And it works, but how do we change the Z order of the tile that we're placing? Now if you look under the tile number, we can find the tile's Z order, and we can change this by pressing Z or X, with Z subtracting 1 from the Z order and X adding 1. And with that, we can finally place this bottom handrail. But before we finally test the map, there's one more Z order related issue that I'd like to bring to light. So if you look at these tiles on the second platform over here, you'll notice that there's a bunch of empty black space that looks pretty ugly. We can easily solve this issue again using Z order, by just setting the Z order to -1. Because the tiles on Z order -1 are often used to fill in blank space left behind by other tiles, this gives them their technical name: filler tiles. With these technicalities out of the way, let's go to the map viewer to see how our map looks in the game. Let's just put this in here, and there we go. The map is now running without issue in the map viewer. We can also see some diagnostic information on the top bar, which gives us the frame rate, camera position, and destination. God dang it! Because we didn't define any collision for this map, we can walk around basically anywhere. So how do we define a map collision? Well, if we look back at the map viewer, we'll notice that there's 3 different modes to choose from: 0, 1, and 2. 2 is the one that we're interested in. If we go to map viewing mode 2, we end up going to this window. I mean, sure, it gives us a nice view of our level and a window to view it through, but this is not this mode's intended purpose. If we go to the folder that stores all the map collisions, which in this case is res/map/collision, we'll notice that a new file has appeared that has our map in it. Now, when working with collision maps, there are 4 colors that are available to you: black, white, red, and light gray. Each color serves a specific function when calculating for collision detection on the tile map. For instance, black you can't enter at all, but white you can walk on. And if you jump in red, you fall down and respawn in the last place that you stood in, while if you land in light gray, you are allowed to jump out, although you can't walk directly into it. I suggest you use paint.net when creating collision maps because they allow you to have the map on one layer and the collision map on the other. Here are 2 methods that I found when making collision maps that can prove pretty useful. The first of which involves drawing rectangles on top of the map data in order to make it fit as best as possible. However, my preferred method with a tile map like this is to just take the paint bucket, press shift, and then fill in a bunch of areas at a time. It's really fast and definitely helps when the map is very big. Now all we have to do is add in 2 black bars on the top and bottom in order to make it so that the handlebars are solid. And there we go, a finished collision map. All we have to do now is to save it back into the collisions folder as the name of the map. In this case, we're going to have to name it bridge.png. If we replay the map now, we can now see that it contains collision data. Now if we try to jump across, we will fall down as expected. And that's everything that I want to show you guys for now. Now, of course, this isn't everything that the map editor can do. Next time I'll talk about some more aesthetic features that the map editor has built into it, as well as how to add enemy encounters to your maps. But anyways, thanks for watching this video. I know that this is a bit of a departure from the previous episode, mainly because I had to get into more of the technical details in this one, but I hope you enjoyed, and I'll see you next time. My name is Simon, and have a good rest of your day.